conservative two-phase locking protocol. Now we can see here, if say two transactions are there and it is say log XA read A write A, log XB read A write B. So that means what it is in what going phase, already you know. Okay, and log XB and here read B write B. So because here it is log XA and B, it is not possible. It is possible that T2 transaction can start its execution. So it is also in growing phase. Okay, now we can see here, if you see this particular example, now log X, that means what, after executing the B part, T2 needs to access the A variable. Okay, but the T1 is already using the A variable and both are what, non-compatible. Okay, they are non-compatible, they are not compatible to each other. That means what, T2 must wait for T1, and but after sometimes T1 needs this particular B variable. But what, T2 is using this B variable and this XX, both are non-compatible. That means what, T1 must wait for T2. So we can see here that T2 is waiting for T1 and T1 is waiting for T2. So that means there is a cycle. Now the deadlock will happen. Now if you use simple conservative two-phase locking protocol, we can remove this particular limitation. Now the concept is very simple. The transaction logs all the required data item before beginning of the transaction. Okay, so before beginning of the transaction, say T1 needs say A, B, C data item. So first of all, log all the data items before beginning of the transaction, then it starts execution. Now suppose C is not available for the C is not available. The other transaction is using C variable. That so T1 should wait for C. Okay, so T1 must wait for all the transaction ABC, then and only it can start its transaction. So the basic concept is what, log all the data item or none. So log all the data items or none. So the transaction wait for all the data logs, for all the logs. Okay, makes sense? So that means what, already you know, say the transaction Ti is there, and so this is the time flows from this direction. Now before, so initial at that point only it logs all the data, then it starts execution, which is not like this, which is not like growing phase. So at the beginning of the transaction always logs all the data item, then it is here somewhere here. So here it is, the commit part is here. Okay, so this is what the conservative two-phase logging protocol. Now we can see example. Now here log X says there read A write A. So T1 needs to read and write, so definitely the transaction needs to issue the exclusive lock. Okay, after that T2 needs B variable, so it's no problem. A and B is there, so T2 is granted for the exclusive lock for B variable read B write B. But after that T2 needs the A variable. You can see A variable, but A variable is what, it is already occupied by the T1 transaction. So conservative two-phase locking is violation of the conservative two-phase locking protocol. So what will happen? So this particular T2 transaction will roll back the T2 transaction, and definitely after that T1 can continue its process by doing this one. Okay, so due to this rollback there is no deadlock. Okay, but the rollback is there, the starvation problem is there. Okay, so starvation problem is there, but the deadlock problem is not there in this particular situation where the rollback is there. Now you can see the another example. Say T1 needs only the A variable, so log this A variable. This is what, growing phase, and this is what, shrinking phase. Now here it is T2 needs A variable and B variable, so it is the growing phase. After that we can write the say unlock A. Okay, unlock B. So this is what the shrinking phase. So this is the example of consecutive two-phase locking protocol. So prior starting of the execution, it locks the A variable. Here it locks the two variables A and B variable. Okay, but one more problem is there, like starvation. See here, dirty read is there. Okay, you can see reading a data from the T1. Say dirty read is there. Okay, so the dirty read is there. That means what? It is irrecoverable. It is irrecoverable. Okay, and one more problem is there. Say prior knowledge of the item must be there. Okay, or the number of item needed must be known in advance. So before starting execution, the T1 must know how many variables it needed. So A, B, C. So sometimes it is very difficult to know how many data items needed to perform the transactions. Okay, but if it is possible to know how many transactions needed, then easily you can implement